Alrighty, so morning. We'll basically pick up from where we left off on Wednesday, looking at some sort of introduction to programming. We've only got a little bit left of that, and then we'll start looking at processing. So if you remember, where were we? I've overshot. So we basically had a bit of a programming refresher. We looked at variables and types and variables and functions and stuff, how to handle arrays, various mathematical operators, comparison operators, assignment, control statements, everything. Everyone was all happy with that? Yeah? Cool. All right, so just to sort of finish off the last little bit of the programming refresher is looking at functions or methods. So naming, calling, arguments, and return types. So let's start with a nice basic processing blank sheet. So let's say, how is that? Righto, never mind. So let's say I'm writing a processing function and I want to draw something. Let's just check it's working. Cool. Set up something 12 by 512 and let's draw a box 0, 0, 5, 12, 0. Two, three. And actually let's just change it from 512 to 255 so we can actually see it. So with a little bit of luck, that will draw basically this box here. So it's not particularly exciting, you know, starting at 0, 0 going to 2550. So these are just x and y coordinates, and then same one going down, and then from there to there to there to there, so on and so forth. So if we wanted to do a bunch of drawing functions, we could obviously do them all in the draw method, but let's say we want to tidy it up a wee bit, we might have our own function, and we can put that code into there, and then we just call our function like that, and with a little bit of luck, looks exactly the same. So what have we done? Well, basically we've created our own function here. And when we create a function, we need to give it a name. So in this case, we call it draw square. Pretty straightforward. How to call it? Well, we just basically call it by the name with brackets on it, so that it knows that it's supposed to. That processing knows that it's supposed to be a method or a function that we're calling. And we can provide arguments. So let's say we want to make this a bit more flexible. We want to be able to specify where the x and y position of it is. We could say, okay, well, let's allow us to tell draw square, here are some functions, x and y, that you're going to use, and just modify this a wee bit. So now basically, every time we draw the square, we can pass in an x and y position, or start drawing from x and y, and then basically draw a 255 by 255 square from that point. So as far as calling that now, all we do is the same thing, but when we pass it in, we pass in our x and y positions that we want to start drawing to. So 10, 10, so you see it's slightly offset by 10 pixels. And, you know, here's 100 pixels by 10 pixels. And return type's the last one. So you see down here it's void, and in all the other methods we've looked at so far, now they're void. But let's say we want to do something where we do a little bit of math, say. So say we want to do a really pointless function which basically finds the double of a number. So we pass in a number x, and we're going to say, okay, well, x double is equal to x plus x, and what we can do now is use the return keyword to return the value of that. So, and we call it exactly the same way, double number 10, and because that returns an int, we can store it like that. Whoops. So you see down here now it's printed the value, or it's printing the value of 20 because we pass in 10, we go 10 plus 10, store that in x double, return x double, and that gets stored in x, and then we print x, and of course we can actually make this a bit simpler, so we could just say print line double number like that, and that'll work just fine. And we can make this one shorter as well, so we could actually say, sorry, return, whoops, if I spell it right, return x by x like that. So we can actually sort of make the whole thing quite a bit more efficient. You probably never write a method this simple, but you know, if you're doing a lot of complicated stuff with 3D geometry or something, it might come in handy to write these methods like that. And at the very least, you know, it makes it a lot simpler to, makes your code a lot cleaner and simpler. Like for example, say we wanted to draw 4 squares at different positions now. And then 100 by 100, 300 by 100. By basically having that draw square function, we can draw multiple squares, and instead of needing to copy and paste all this code and update all the variables at each time, we can just have one line which calls it with these new updated variables, and it'll work accordingly. So the other thing we can do in processing is a process known as overloading. So if you remember, when we first wrote this method, we had just draw square like that, and that basically would draw a square at 0, 0 by 255, 255. So let's say, you know, we're building on top of someone else's code, and we want to make sure that we don't break it so it still works for other people, but we want to extend it a wee bit. What you can actually do is what's known as method overloading. That. Just comment these ones out. So now I've basically given sorry. So if you remember the original way our method worked is it would draw a square of 255 by 255 starting at 0, 0. But now because I've added these arguments here, which basically say, you know, this has to be, well, you have to tell me where you want it to draw x and y. If I was building on top of someone else's library, say someone else had written a library where it only ever draws squares at that position, and I say, well, I want to make it a bit more flexible, then if any other piece of code uses that person's library, it's going to need to be updated as well. So what we can actually do is use these, what are known as method overloading. So we use the same name as the method, but we can have different arguments in it. So in this case, if we call draw square without any arguments, it'll call this version of draw square here. If we call draw square with some arguments, it'll call this version of draw square here. So basically looks to see what arguments are getting passed in, and then uses that to determine which of these methods we want to call. So the bonus about this now is, you know, I've changed the draw square method, so now we can specify the the x and y position at the starts. So if I had, you know, if I didn't have this method here, and I called draw square, I'd say, in fact, I'll show you. There's comments. So if I try and call this now, it'll say, oh, the method needs 2 integers, you can't pass in nothing. So if I updated this library and then gave it to everyone else who was using it, it wouldn't work on their code anymore. But instead what I can do is I can provide this overloaded method, which basically mimics the functionality as it was before by calling draw square at 0, 0. So it basically calls our new method but at 0, 0. Then if this person tries to run their code, it'll work. And as far as they're concerned, the library hasn't changed at all. Well, yeah, as far as their code's concerned, the library is still exactly the same, but we now have given ourselves the ability to actually do some more advanced stuff. So again, these are very simple examples, but you know, it basically allows us to have multiple, you know, we might want to draw a square and just put it wherever we might want to say, okay, let's make sure that it's always at the same place. And by doing that, you can do things like optional arguments as well. So let's say I want to have another function prototype now. Let's say I never want to give the person control. Well, I want to have a method where people can control the x position, but not the y position. I could have another one which just has the int x. So now I have 3 different ways of calling draw square. I can call it with no arguments, in which case it'll call this one. I can call it with 1 argument, in which case it'll call this one. And I can call it with 2 arguments, in which case it'll call this one. and they all work just fine and dandy. Cool. Everyone happy with method overloading and stuff? It's can be quite powerful and quite useful. Yeah.
Is void just the standard syntax?
So void is the return type. So you remember we had said, this one returns an integer, so we add two numbers and return the integer. Void basically means we return nothing. So void is a special data type, which basically means nothing. There's nothing in there. So yeah, basically when the processing sees this, it says, okay, this is a method draw square, but it's not going to return anything. So I could have return like that, and that just lets it know that that's where the method finishes. But if I try and return anything else, it will say void methods cannot return a value.
Oh,
yeah. So it's basically just to let it know, that nothing's going to be returned from this method. Right. So yeah, classes and objects. This is the last thing we're going to cover before we move into more in-depth processing, pretty much. And in fact, yeah, we'll talk about this in like 2 slides. So, yeah, but the idea behind classes and objects is you're trying to encapsulate a bunch of data within a common thing. So, the common example is like a car. So you have a car, and a car has 4 wheels and an engine and all these sorts of things. So you could have your 4 different wheels, like in your main class, you could have, or your processing thing, you could have a car with 4 wheels and an engine and stuff, and then each of them needs to know the relationship between each other. Whereas we can encapsulate it all within a car object, and when we say car drive, it's up to the car to figure out, how the engine works, how the wheels work, and all that sort of stuff. It's not up to the person writing the code. So that way, if I give you my car object, you can say drive, and the car will drive. You don't need to implicitly know how the engine drives the wheels and all these sorts of things. So it's to encapsulate a bunch of data and a bunch of methods which all sort of work together in a way that, ideally a well-written class, you should be able to use it as what's known as a black box. So you don't really need to know what's going on inside. You just need to know how you can make it do things and what things it's going to do. You don't need to know, the implicit workings of the car, just how to say drive and the car will start driving. So classes can have properties, they can have methods, these methods can be public and private, and they can inherit off each other as well. So you could say, okay, well, let's have what's known as a base class of a car. So we have a generic car, and then you could have, let's have a Toyota, let's have Nissan, let's have whatever else, and each of those are types of cars. So they all do what cars do, but they might do it in slightly different ways. And as I said, we're going to have a look at this in a minute as well. But one last thing I wanted to touch on briefly is scope, because scope can be quite confusing and screw people up quite badly. So let's see, if I have, where are we? Down there, with setup. And just call that my method. Right. So if I have in here, in setup, we have this variable x, and we set it to 0, and then we call print x. Now, if I have in this one and this one, so basically what we've got here is we've got multiple copies of x. We have one which gets set to 0, one which gets set to 5, and one which gets set to 10. And then we print out the values. So we should do too much. So when this first runs, it's going to call setup. Setup is going to set its copy of x to 0 and print x. So 0. Then every time this method runs, it's going to call draw. And draw is going to have this variable x that it's going to set to 5. It's going to print that as 5, and then it's going to call my method. So down here, my method has its copy of x, which it sets to 10. It's going to print x, and then it's going to exit back out, and it's going to run this line and draw. So what's this line and draw going to say when it prints x? Yeah, 5. So if we see, it'll go 0 and then 5, 10, 5, 10, 5, 10, 5, 10, so on and so forth. So you might be wondering, well, how come we set x to 5 here and then it's print it and it's 5, but then we set it to 10, print it and it's 10, but back here it's 5 again. That's basically the idea of scope. So scope defines how long a variable or whatever lasts for. So in this case, because we're defining each of these x values in here, their scope only, basically, the easiest way to think about it is if you look for the squiggly brackets, and I'll show you why this is important, the variable or the scope of a variable only lasts as long as its nearest set of squiggly brackets. So you might as well think of this one as being like setup x, draw x, and my method x, because none of them, despite the fact they all have the same name to us, as far as processing or whatever language pretty much you use is concerned, all of these are different variables. They have nothing in common with each other. So that's why when we say print x here, we're essentially saying print draw x. Here we're saying print my method x. So this makes it a little bit clearer to see that when we say here print draw x, and in here we say my method x is 10, when we come back here, we're still actually printing this one here. We're not printing this one down here. So we can actually do what's known as global scope variables in processing. So I can define something out here, and actually just as another thing, so get this working. So yeah, you know, if I now, say in my draw method, if I want to print the x value which I stored in setup up here, I'll be told that it can't find anything because the scope of setup x only lasts as long as these squiggly brackets do. And the same thing here, if I want to print draw x, even though draw x called my method has no idea what draw x is because the scope of draw x only lasts as long as this draw function. And the same thing goes in reverse as well. Even though draw calls my method, it has no idea of what this my method x is because the scope of my method x is limited to this. So what we can do is we can have these what are known as global scoped variables. So this one here, we have it outside of the brackets. So effectively you can imagine this one looks like this as far as the squiggly brackets goes. And so that means this main x can be accessed by all of these. So I could say this one print main x, and that will be just fine. It'll be able to print the value of main x because the scope of it allows all the methods to see it. Oops, that's not what I meant to copy. And of course that'll be the same for all of these methods because the scope of that main x is global, so everything can access it. The reason why this gets a little bit confusing is let's just do 5 times. We'll get rid of that. Now, I would never recommend writing a piece of code like this because it's going to be more confusing than it's worth. But here you see we have int draw x equals 5, and then we print the value of that, and then we have this for loop here as well. And inside this for loop, we also define int draw x equals 10, print draw x, and then we print it outside again. So now, okay. So in this case, Java's actually smart enough to do it. So it's actually beaten me to it. But in C or whatever, this is valid code. So in C, basically, you'd have this x function here would be, this draw x value function here would actually be completely different to this one out here. So it's just something to keep in mind. Yeah, and there's actually other ways as well you can sort of exploit this. So let's trying to think of a good way to do this. Oops, for int I equals 0, I is less than 10, I plus int my x equals 10. Stop doing them to 10, let's just do them to 5. So yeah, in this one, you see now we have, within this draw method, we have this myx here, which is set to 10, this myx here, which is set to 20, and you see we get 5 10s and 5 20s. So even within, despite the fact Java was, or the processing Java implementation was smart enough before to tell me, look, you've already got a variable named drawx within the scope. If you do 2 of them, you're going to pack sad. We can actually have, within this draw method, we can actually have 2 myx's. Because the scope of each of these is limited to these sets of, this set of squiggly brackets and this set of squiggly brackets for the 4 thing. So yeah, I mean, scope is generally, if you name all your variables differently and ideally don't call them X, Y, and Z, you give them some name which actually means something. You know, generally you shouldn't have too many problems with scope, but if you're running into really weird problems, it's often worth having a look at the scope of what your variables are, because it might be that what you a variable that you think is being modified is not. You're actually modifying a different variable from a different scope or something. But yeah, everyone sort of get the, you know, the idea of why scope is important, just to be aware of. I sort of threw that in there, you know, as a last thing, just because it's something which can catch people up quite often if they don't know what's going on. But yeah, so now let's just finish up these. So these are the first set of slides that we were covering last week. And looking more specifically at programming and processing. So processing is built on Java, which is an OO language, although it removes some of the reliance on OO to get started anyway. Some internet is not working. Oh, there we go. So yeah, there's a nice little description for newbies of what OO means and how it works here. Little being, you know, perhaps up to interpretation, but basically it has an idea or it has a description of what OO is, and if you're not particularly familiar with it, you know, it's probably good to have a little read over, but it's basically sort of, you know, a better description of what I've been saying, with the idea that classes encapsulate a bunch of information and methods which are specific to a typical object. So, for example, they have the idea of this human object. So humans have a bunch of data. You have your height, your weight, your gender, your eye color, your hair color, and for each human, like each human has this information. So I have a certain height, weight, gender, eye color, hair color. So do you, so do you, so do you. It's something specific to all humans, but for each human, it's going to be different. So each of these values is going to be different. So we know that, you know, these are things which are common to all humans, but going to be different. So we can store them all, and then we have a bunch of functions which are specific, or which are, you know, shared by all humans, but specific for each human as well. So everybody sleeps, they wake up, they eat, they ride some form of transportation. So the idea is we can create multiple versions of humans using things like inheritance or whatever, or, you know, for the data, we could create multiple versions of the same human, but assign different data values in it. And then for human functions, you know, you could have a human who rides a bicycle. So when you say ride transport, it'll execute some bicycle riding code. You could have a human who drives a car. When you call use transport, it'll call the drive car thing. But we don't actually need to know specifically how you ride a bicycle, how you ride a car. That's up to the person who wrote those implementations of the human. So we're trying to sort of encapsulate a bunch of data and hide it away so that we don't need to know specifically. We don't need to say, oh, here's a human. Okay, let's find out, you know, what sort of transport they write, and then we'll write the things, because we'll write the method for how that works. The main idea being, you know, one, it hides a lot of stuff that we probably don't really need to know about at any point in time. So, you know, I don't really need to know how somebody drives a car in order to tell them to drive to school. It also, in some ways, future-proofs as well. So, say I write, you know, a model of the world, or a model of people in the world right now, and I say, okay, people can ride a skateboard, they can ride a bike, they can drive a car, and then, you know, 100 years after I die, people are still using this model, but now jetpacks are fairly commonplace. There's no way for me to predict how how Jetpack's supposed to work. But somebody can then basically take my model and say, okay, well, let's make a new version or new implementation of the human class which has a jetpack, and without needing to go back and change all my code, they just say, oh, well, this, Adrian wrote this thing where it says, okay, humans have some sort of ride transport, so I'm just going to say, here's a new person with a jetpack, and I'll write the jetpack code, and everything else will be the same. So yeah, it basically, there's a lot of good reasons for using OO, and I'm sure this probably goes into far more detail that I'm planning on it in this class, so it might be worth having a look over. But yeah, encapsulation, so hiding a bunch of stuff we probably don't need to know about, and future-proofing are probably two of the main ones. Yeah, so objects group together multiple related properties and functions, so for humans, height, weight, whatever else, and functions, sleep, eat, whatever. Objects are defined by object classes, so we basically write a definition of an object, what things are particular to that object, and then when we create an object, we fill out the things. So all of us here might have the same person object, but then when we create an Adrian person, we set his height to this, his weight to this, and so on and so forth. Or using cars, every car has a color, it has a location, it has a current speed, and then every car has a drive function. Otherwise, it's pretty useless. And because we're talking about graphical programming, we might have a draw function, so we might want to be able to draw the car on the screen or some information about that car on the screen. So classes basically come down to having four main elements. They have a name. So class car. So that basically means the class's name is car. It's pretty straightforward. And again, you see these squiggly brackets here, so we're defining scope. So everything within these squiggly brackets is going to be specific to cars. Everything outside isn't. Then we have some data. So let's say color, car color, or just whatever. Int speed in kilometers or something. A constructor. So a constructor is a special type of method. So constructor doesn't have a return type, so we don't need to say void or anything like that, because constructors can't return anything. They're basically used to create a copy of our object. So for a car, for example, we might say, okay, well, when we create a car, its speed in kilometers is going to be 0. So we're not going to create a car and it's going to be moving. We're going to say it's at 0. And of course, like other methods, we can have multiple overloaded constructors. So we might have this constructor here, where we can pass in a color. And so when we create our car, we say, create a new car, and it should be blue. And then it'll set the value of the car's color to blue and set its speed to 0 again. So if I don't specify a color, this will be undefined. Essentially, it's got no value. And the speed is 0. If I do specify a color, it'll store that color of the car in here, and then it'll set the speed to 0, and so on and so forth. And then we have methods as well. So and so on and so forth. Oops. I was going to say, I bet this is all right, let's make it a string instead, because I can't remember what the color thing is. So our color is now a string, so it can be anything we can fit in there. So there we go. So I have my class car, and when I run it, it does nothing. Because I basically defined what are properties and aspects of a car, but I haven't actually done anything with them. I'm saying these are things which are specific to a car, but we don't actually have any cars. So let's create a new car. So this is my car. And I can say Adrian's car dot speed. We draw dot drive. Hopefully I've done this correctly. Oh. Right. So car equals new car. Right, so we have up here our definition of the car. So, you know, cars have a colour, they have a speed in kilometres, they have two constructors, one which takes no arguments, one which takes a colour. The one which takes no arguments sets the speed to 0. The one with colour, with the colour sets the colour of the car to that, and sets speed to 0, and a drive method which just prints I'm driving. So down here, so you can basically consider this two separate things. Down here now we have my function, or my main code, which actually does stuff, and I have this global scope car called Adrian's car. So this is my car here. In the setup method, I have to create a new car and set Adrian's car to be that. So my car is silver, pass that in, and now I set the speed of my car. So if we ever want to access a property or a method or anything which is contained within the scope of this car to something, we have to use this dot operator that's basically saying Adrian's car, so get this copy of the car and set the speed in kilometres variable to 10. So it was 0, now we set it to 10. And then in the draw method, we just call Adrian's car dot, so we're going to get this one and call the drive method on it, so it's going to print I'm driving. So let's make this a little bit more, oops, this keyboard.
So using the dots kind of like you set up the constructor to put data into the object. It's using dot notation kind of the same job, or it does a similar job?
So basically using the dot allows us to access variables and methods within the scope of car. So we talked about scope before. So, yeah. You know, if I just said drive like that, it wouldn't know what to call drive on. So I'd say, okay, is there anything with the scope, anything called drive in my scope? And say, no, there's not. If I say Adrian's car.drive, it says, okay, we have to find what's in the scope of this object. So that's everything in here, and call it. Certainly, I could have a constructor which did nothing, and then I could set all the variables myself using just dots. So you know, I could not set speed in kilometers, I could not set the color, so on and so forth.
So you could set the color with the dot as well.
Yep. So I could go Adrian's car, say I get it resprayed. I could go color equals blue, like that. The idea behind a constructor is it allows you to sort of set, if there's things which have a typical value, you know, you might want to set them in the constructor so that you don't have to worry about doing them later on. Yeah. So, you know, if all people, well, I'm trying to think of anything of people which isn't common, probably not much. But, you know, for things like a car, for example, or like a car maybe better than speed in kilometers might be, you know, your odometer reading or something, how far the car has traveled. All cars start at 0 and then they go from there. So yeah, you can access anything, any publicly scoped variable, and we'll look at public and private in a second, using the dot notation as you can using the constructors. Constructors just provide you an easy way to basically set it up as if it would be for the first run. So now,
the underscore and the color that just came on it.
Yeah, so I just put it in there because I couldn't remember if there was a color method. So if it was use the same name, so yeah, I'll get that out just so it looks the same. So yeah, now we've modified this a little bit. So I've got I'm driving, and it now says this current speed I'm traveling in kilometers. So let's create a new car 2, and say car 2 equals new car. We won't give this one a color because it's not that important. But let's say car 2 is like way faster than mine, and it's traveling at 100 kilometers an hour. If I go car 2.drive now, you see we have I'm driving 10. So this is Adrian's car is driving, and it's traveling at 10 kilometers an hour. And then I'm driving 100. So this is car 2, and it's traveling a lot faster. So both of these are printing out their own I'm driving plus speed information. So you can see now, like if you wanted to do something like, say you wanted to make a car racing game or whatever, all you got to do is implement some stuff like, you know, draw the cars on the screen. So you might have boxes or whatever, And rather than needing to keep track manually of, oh, here's car 1 speed, here's car 2 speed, blah, 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 you can basically just write the implementation or the class for car to handle all that stuff yourself. And all you need to do is tell the car, okay, start driving. So if you wanted to do like, something really fancy, physics with physics engine stuff, you'd probably put all the physics within the car model so that you don't have to worry about at each turn trying to make sure all the physics is updated correctly. You just tell the car to drive and it would update its own physics and everything like that. Now, I mentioned a couple of slides ago the idea, so we've looked at the idea of encapsulation, we've looked at properties and methods, so that's the properties of the data basically, and the methods are the things you call. The only thing we didn't cover here is the idea of public and private. So we talked about scope before, how we can say, okay, well here's the scope of these methods, string and color. We look for the outermost encapsulating brackets, and it's these ones here. So I can access them by calling, Adrian's car speed in kilometers, Adrian's car.color. But let's say there's something, odometer. So let's say I have this odometer thing, and I don't want people to be able to tamper with the odometer because it's legal. I want the odometer to start at 0. And each time we call drive, we're going to increase the odometer by the speed in kilometers. And we'll also print out here the current reading of the odometer. So now what's going to happen is each time I call drive, it's going to increase the odometer by the speed. And yeah, so if I go play, so you can see now this is my car driving along, and it's currently done 20,000, stop this. It's currently done 3,900 kilometers, and the other car has done 39,000 kilometers because it's traveling 10 times faster. But let's just say, I want to then go and sell my car. I could just go Adrian's car dot odometer equals 10. There we go. Now, I can wind the clock back on my car and look, no matter how far I drive, I've only ever driven 10 kilometers. Brilliant. So we might not want to allow people to do that. So what we can actually do is we can use the private keyword. And private basically means, okay, I'm changing, like, each thing when it gets its scope, it sort of has this default scope depending on what's in it. So, in this case, it's allowed to be accessed by things other than the car. But if I define it as private now, when I try and run this, okay, that didn't work. That's not great. We might have to come back to that a little bit later. I'll have to try and figure out why that's not working. But basically, the idea behind public and private is private sort of limits the scope to the encapsulating object. So if this was working as it should have been, I basically would have told me, oh, this is a private method. You're actually not allowed, or private variable. You're actually not allowed to touch this one. Only car can touch it. So car will be able to update it, but outside that, I can't crack it open and start fiddling with that. But I'll try and figure out. Maybe we'll have a little 10-minute break in the middle of the lecture, and I'll try and figure out why that hasn't worked, because it should have. Yeah. But so that's the idea, and obviously there's public as well as the other main one, which basically just says, yeah, everyone's allowed to do it. So we could do other things as well. We can have public and private variable. So say I want a private one in here. Well, it's private for a car. Let's say change oil or something. So I can get in there and I can have this private method change oil. So no one's allowed to change the oil, but then I might have a method service. So the car can change, well, the car's oil can be changed during a service, but you can't get out there and change the oil yourself. I know this is a really terrible example, but I'm sort of running out of ideas with this car metaphor, unfortunately. But you can basically have these private methods which only this class is allowed to call. So it's not allowed to, like, I can't, well, theoretically I shouldn't be allowed down here be allowed to say change oil. But it's going to let me anyway, so I'm not sure what's going on here. but I shouldn't be allowed to change oil, but I should be allowed to call service, which would change the oil. So we'll figure out why that is not blocking me, and we'll come back to that at a later date. But yeah, so this is the example that they give on the processing website, which is potentially better or worse than my one. I'll leave it up to you to decide. So this is actually the color object. It's color with a lowercase c, not a capital C, for some reason. So the reason I thought that is because processing tends to, if we look in the reference, we have what are known as primitive data types and composite data types. So a primitive data type is something like an integer, a float, or something like that. Composite data types are usually more complicated. So, for example, in primitive we have a char, which is a single character, so a letter of the alphabet. In composite we have a string, which is a series of characters, so it's one or more characters. Primitive data types start with a lowercase c, or a lowercase letter. Composites start with an uppercase letter. It's just the naming convention they decided to go with. This is the reason they've done it this way. I expected that color would have been a composite one, because usually you have a red, green, and blue element to a color, but apparently that's not true for that's not true for processing. So that was just an assumption that I made, which turned out to be wrong. So yeah, if in doubt, check the reference, because it's all in there. But yeah, so basically most of the basic things, the more primitive things, will start with a lowercase. The more complicated things usually start with an uppercase. That's pretty much the main difference. I assumed color would be a composite, but it's not. So their one is kind of similar. They have color C. They have an X position, a Y position, and a speed that it's traveling in the X dimension. And they have their constructor here, which basically sets a car to white by default. Its position is half the width of the screen, so width is a special word in processing which defines the width of the screen. Height is a special word which defines the height of the screen. So this basically puts a car in the middle of the screen, which is white with a speed of 1. So they've written, in their display method, they basically draw a rectangle to show the car, and this is in the car's definition. So the car can display itself, and when you call car to display, it'll draw a filled rectangle at its position, and when you call drive, it'll increase its speed, X position by the speed, and if it drives off the side, it'll put it back at 0. So let's really quickly whip this up. Let's start a new sketch so I can have a look. Class car, color C, float X pos, float Y pos, float X speed, 255. It's one void display. Pause, Y, pause. Almost there, void drive. Right, so what's the called car? So let's create a new car C. In our setup, void setup, we say C should be a new car. And then in our draw method, it's C.display. Whoops. No, whoops. Not X speed. And actually, let's just set the size to a bit bigger. Oh, I need to drive it as well. So there we go, there goes our car, which is leaving behind a trail for some reason. But yeah, you can see the car's basically, we are calling drive, so it's moving the position of moving the position of the car by X speed, so 1 to the right. Once it goes off the edge, it puts it back at 0 and goes again. And then when we call display, we just draw a rectangle at the X position and Y position of the car. So we could make this a bit more exciting, you know, make it so you can turn the car and drive it around and stuff like that. But yeah, that's why I was drawing trails, because I never actually reset the background. Set the background to white. There we go. So now the car's drawing. We need to clear the background, otherwise it just draws over what was previously on the window. So yeah, we have our car, which is slowly driving across the screen. Not particularly exciting. So this is the example that another example they give, creating a frog with a constructor. So frog length. The frog's constructor takes a tongue or temporary tongue length and assigns that temporary tongue length to its tongue length variable. We can create 2 cars now. So car C2. C2 is new car. And just to make them slightly more interesting, let's move YPOS down by 50 and X speed equals 10. So it's going to be 50, C2, car 2 is going to be 50 units below car 1, and it's moving at a rate of 10 rather than a rate of 1. So and it's all lowercase. So there we go. So now this is car 1, which is pedaling along. This is car 2. And this is pretty much the same as the example I gave before. This is my car, this is the other car, except my car's odometer is currently constantly being reset to 10 for some reason, even though it shouldn't be. Yeah, so modifying the constructor, we sort of already looked at this, so you can basically specify other constructors. So in this constructor for car, we allow someone to pass in the temporary color, temporary X position, temporary Y position, temporary X speed, and we just set all those values. But we could either do it in the constructor, or as you said, we can do it like I've done here, where I basically just set the values out here. It's all fine and dandy. And we'll take a little break there, because that finishes off the lecture notes from last week. And then we'll start again in, I don't know, 10 minutes with this week's lecture notes. Cool. If anyone has any questions, just let me know. So yeah, feel free to grab a drink or go to the bath. Alright, so we'll get back into it. So we've finished off with those examples. And to this one. Alrighty. So processing is a language of interaction, or so they say. Basically, to make it easy to make interactive programs and stuff like that. So let's get into some actual interaction. Did anyone have any questions about any of the stuff we covered so far? By the way, we should ask this. Hopefully it's all fairly straightforward. And yeah, just practice is probably the best advice I can give. But yeah, so let's put together a basic little thing. Void draw. So yeah, interaction. We want to be basically allowing people to interact, funnily enough. So doing things like interacting with the keyboard, with the mouse, etc., etc. And processing actually makes that quite easy. It provides, I should have left that one open. It provides a bunch of input functions, like things with the mouse, the keyboard, mouse, keyboard, and files, date and time, input, and stuff like that. Make it really easy, whereas sometimes these can be a bit trickier to get out of other programming languages. So let's have a look at some mouse-based interaction. So we have access to a bunch of different things in processing, like the X position of the mouse, Y position, the state of all the buttons, and so on and so forth. Let's just write some code up to have a look. So we have this little window here, and you can see down here we're printing out the X, Y, and buttons. So as I move it around, you see the X and Y updates. And I click button 1, and it says 37, button 2 is 39, and middle button is 3. Pretty sure there's actually things to make that a little bit easier. Yeah, so left, you can use left, right, or so on and so forth to basically decode what those values come out. So left, right, or center. We also have various methods we can call. So we can call mouse pressed. So print mouse was clicked. So now if I click the button, let's get rid of this so I can actually see what's going on. If I press the button, it'll say mouse was clicked. And mouse, so that's basically pressed fires once when the mouse button is pushed down, and then we have mouse released, which is fired when the mouse button is let go of. So mouse was clicked, mouse was unclicked, and mouse dragged is when the mouse moves with the button down, and one other one I should have put in there was mouse moved, which is when the mouse moves at all. So this one is when it moves at all, this one is when it moves at all. Let's double check that void. And it's dragged. Yeah, so mouse moved is whenever the mouse is moved with none of the buttons pressed, and mouse dragged is whenever. No worries. Mouse dragged happens whenever the mouse moves and one of the buttons is pressed. So we can make a nice basic drawing application if need be. By just doing something like this: line P mouse X, P mouse Y, X mouse Y. So P mouse X and P mouse Y are special variables again in processing, which contain the coordinates of the mouse at the last time the draw method was called. So by doing that, we can draw stuff on there. Basically, it draws a position at each frame from where the last position of the mouse was to where the new position is, and so we can draw all sorts of squiggly stuff on there. Now, just one thing to keep in mind with these things, a little bit of a gotcha if you don't know it. If you don't have the draw method in there, nothing will happen. So this is just something which processing forces you to do. If you look in the documentation, it does say in there, I think in the mouse dragged. Yeah, mouse and keyboard events will only work when a program has draw. Without draw, the code is only run once and stop listening to events. So we're just saying if you're going to be using mouse drag, mouse moved, or any of the mouse events, make sure you have a draw method. If you don't, nothing will happen. So yeah, it's just a little bit of a trap for new players. And we ended up making this where you can just draw stuff by clicking down the mouse button. Nice and easy. Keyboard interaction, pretty straightforward again. We can check to see if any keys were pressed using the key press variable. Or alternately, we actually have a method which will fire whenever whenever a key is pressed. So key A pressed and pressing A. You see they're basically firing. Both of them are firing whenever I press it. So processing does this for both keyboard and mouse. As we saw before, we can get the mouse X position, the mouse Y position, the mouse button position in draw just as variables, or there are methods which will tell us when a mouse button was pressed or released or whether the mouse was moved. And with key press, we can check the key pressed variable. If it's true, then we can find out what key was pressed, or the method will fire. So we can either do everything ourselves, like in the draw method or whatever, or we can rely on an events-based system, which every time one of these things happens, these methods will fire and we can catch them there. So there's sort of multiple ways of doing the same thing in processing, depending on what you want to do. So it will only fire if the key is pressed. So if key pressed gets called, a key has been pressed. If no key has been pressed, it won't get called.
In if condition, we are checking if it's true or false.
Yep.
Whereas we are defining it as void. Yesterday I was trying something on processing, and then I used mouse pressed.
Right.
So when I used mouse pressed with if condition, it was saying that it's not a boolean, it's a void.
Right. So yeah. So there's multiple things going on here, which is probably may make things more confusing than they need to be, unfortunately. So mouse pressed is, I don't think there is a variable called mouse pressed. Whoops. Might be. No. So there is a variable and a method. Yeah. So you can, like, most of these things you see, so we have mouse pressed, which is a Boolean variable, and then you have mouse pressed, which is also a void method. But they're, as far as the programming language actually goes, they're completely different things. But processing basically allows us to use either of these. So, you know, if you wanted to, you could, instead of doing, there's basically two ways of doing things like input detection stuff when it comes to programming. You can do what's known as event-driven, which is what we use here with the variables, where when something happens, it calls our method and we can handle it. Or we can use what's known as polling, where we check ourselves to see which of something's happened. So you can write things, they're both basically the same thing, it just depends on what you're doing, your own personal preference and stuff, whether you use the event, which is basically like the processing tapping you on the shoulder and going, oh hey, somebody's pressed the mouse, or whether you do polling, which is where you ask processing, has anyone actually pressed the mouse button or not? So it's the same thing, it's just sort of different ways of doing the same thing, and it depends on, you know, your own personal preference, what you're trying to achieve at the time, and all that sort of stuff. Yeah, so that's a sort of a brief look at mouse and keyboard interaction. We'll have a look at graphical controls a wee bit now. So obviously we can draw our own graphical controls using boxes and all other bits and pieces and stuff, and there's probably some default stuff in processing, so there's some GUI stuff for buttons and whatnot that we can have a look at. So here's one which makes its own buttons by drawing circles and rectangles and stuff. So when we click on them, various stuff happens. So this is all done in the code by basically drawing a rectangle or a circle, and you know, if the mouse is over them, it changes the color. If you click on them, something else happens. So you know, you can certainly do all these things yourself. So you can do, here's ones with handles that you can click and drag out, and I'm sure if we look in here we'll see it drawing rectangles and stuff. So you know, if you want to, you can make all your own GUI things, buttons, windows, all that sort of stuff. Slightly cooler one. However, that can be quite tedious. So what you might want to do instead is use one of these external libraries which allow us to do GUI-based stuff. So we're going to have a brief look at one called Control P5. So I'll make these lecture slides available to you guys as well. Has Loon been set up yet, or does everyone have access to it?
Should get access to it today, I think.
Okay. Right. Yeah, or if not, we can I can email them out to you or whatever. as well, so you have all the links. But yeah, so there's control P5. It is this have pictures? No, so it has lots of code. Oh, there we go. So this is control P5. So it's basically a GUI library which allows you to do nice GUIs and stuff, and it handles all the sort of interaction and bits and pieces itself. So you start up here, you click on basically download control P5, and it's going to take forever, but I downloaded it earlier anyway. And just minimize some stuff. Then if we look at the install instructions, it's quite good. It tells us how to install it all. So, basically it says you need to drag it into the your assuming you're using Windows, My Documents Processing. So if we open this, My Documents Processing, and then this folder is created by default by Processing. Then you go into Libraries and you just dump. Within the zip file, there's a control P5 folder that you can just dump in there, and you're away laughing. Now you'll have to restart processing. But yeah, so now if we look into this, you see if we go to Sketch Import Library, let's actually just new Windows Sketch. Jesus. Okay, let's try that again. No. Let's just use this one then. Import Library, you'll see there is in the contributed folder. So these are basically libraries that you've added. There's control P5, and if I click on that, it'll just import control P5. But probably more interesting is if we go into examples, and same thing, if we look into contributed libraries, control P5, and there is a bunch of examples on how to do stuff. Somewhere in here there is one which does like a whole bunch of them. Yeah, but yeah, so you can have a look through the various ones that they provide and see how they work. So there's some sort of checkbox where you can, I don't know, click on various stuff, and there's lots of other different ones in there. So basically, it's a graphical library toolkit which makes sort of it a lot easier to work with GUI elements without having to draw them all yourself and so on and so forth. So supports buttons, sliders, etc. It's got support for open sound control. We'll look at a bit more open sound control later in the course, but basically it is a networking language, so it allows you to communicate over a network connection. And originally it was done for controlling MIDI devices and so on and so forth, but it's since been expanded to basically support anything. It's nice and easy to use. It's got a human-readable protocol format and so on and so forth. But the important part here, I guess, is that control P5 supports it by default. So basically you can hook your control P5 widgets to control stuff using Open Sound Control. So if you had a MIDI controller, for example, you're using a sound desk to control some sort of stage performance, you could write your GUI in Open Sound Control and then have it control your sound desk if it supported Open Sound Control. As with Open Frameworks, as with processing, it has a reference library. It's done using JavaDoc, so it's not quite as pretty as the one which processing has. But if you go to the main reference thing, you have a list of all the classes. So accordion, bang, buttons, charts, all sorts of bits and pieces in there. You can have a look at, figure out what they do, what's interesting to you. Yeah, but these are some of the example controls. So you have list boxes where you click down and there's a bunch of different things you can scroll down and check on. Multi-level lists, so you click on one and then it has multiple levels. Radio buttons that you click on, and you can select 50 or 100 or whatever. Ranges, so you can set the minimum and the maximum range, something. Text fields, number boxes, which are text fields which only support numbers. Check boxes, so you can check multiple ones. Buttons, sliders, volume knobs, horizontal sliders, etc., etc., etc. So let's try and do our own little example, if I can. Where am I? So let's create a new processing example. Go sketch. Oh, somewhere in here is the import. There we go. Oh, I lost it again. Yeah, so it's not going to let me do that because the processing IDE has packed sad. Actually, let's just close down the whole thing. Try that again. There we go, that's better. So yeah, let's go into Sketch, import library, and import Control P5. Now the way it works is a little bit weird, but basic. Whoa, what's going on? Brilliant. Yeah. So we have this Control P5 object. So if you remember before when we had our car object, we have to create a new car. Like we had a car class. Sorry, we had to create a new car object. So we had car, my car, or whatever. It's the same thing with Control P5. So Control P5 has this Control P5 class that we have to create an instance of, and then set up. And you'll notice this is true for a lot of the libraries which run in processing. You need to have in your setup Control P5 and this, which basically allows it to hook back into all the processing methods like the events like mouse drag, mouse drop, and all that sort of stuff. So it allows it to get access to all the processing stuff we need to when we create our Control P5 object or anything else. We need to say new Control P5 and we pass in this, which is basically a reference to the current processing sort of runtime piece of memory. Once again, as with before when we're looking at mouse pressed events and all that sort of stuff, we need to make sure we have a draw method, even if it's empty, otherwise nothing will show up. And then we can just basically go and start creating new items. So let's say we want a button, equals cp5.add button, and let's call it button 1. And we'll do a color picker. I'll pick 1 equals cp5 add color picker. And I should have made the window a wee bit bigger as well. So now we have a new window, and it's kind of hard to see. There's a color picker there, and behind that is a button because it's basically putting them at 0, 0 because I haven't told them to do anything else. But yeah, our color picker, we can basically select a red, green, and blue value, and you can see down the bottom it's reflecting red, green, blue, and alpha actually, and it reflects on the bottom what that color is from a combination. But you can see there is a button behind there. If I actually reduce the alpha, you can just see it there, and I can click on it, but pretty hard to see, so let's move that button out of the way. Button 1.set position. Hopefully that'll be enough. Yeah, so there it is down there. Yeah, so we got a color picker in there now and a button to do some stuff. So pretty easy to set up, and they now do stuff as well. And again, if we look in the reference library, it has all the information for how to do stuff like set position, set size, all that sort of stuff. So there's something kind of neat about Control P5. So let's say I want to do a bunch of operations on button 1. So I want to change its position, change its size, and all that sort of stuff. You can imagine. So at the moment we're only changing 2 properties of it. We're changing its position and its size. However, the way CP5 or Control P5 works is that actually each of these methods, so the add button is a method or a function, set position is a method or a function, set size is a method or function, but they're not actually void functions. They actually return a reference to the original object. Now I know it's probably a bit confusing to figure out what that means, but it basically means we can actually string all of these together in one line if we want. So rather than needing to do each of these on its own line, we can actually do with one line of code set up our button exactly how we want to look. There we go. Which just it's a neat little feature. You don't have to do it this way, and if you find it too confusing, don't do it this way. The main reason I bring it up is because if you look in the examples, a lot of the examples show it done in this way. You basically call add button, and that creates a button, and then you set that button's position to 200 by 200, which returns a button at that position, and then you tell it to set button size to 200 by 100 and so on and so forth. But yeah, you can string them all together, which makes it look a little bit nicer. So yeah, once again, as with all things in processing, event handling can be done in a number of ways. So we'll start with the easier way first, actually. So you see up here, when we create a button or a color picker or whatever, we give it a name, so a string. So we call it button 1, picker 1, whatever. Now this is quite important because this is basically how we're going to reference these objects from now on. So button 1, say we want to find out if anyone's pushed it. We have this method here which gets automatically created for us called button 1 because it's the same name as that. And all of these methods control P5 creates have the same function, so void and then the name of the function and then int value. And button 1 was pushed. And that gets set up by control P5 to basically be an event which listens for when something happens with that button. So if I click on that, you'll see button 1 was pushed. So if I now change this to my button, if I try and run this again, you'll see nothing happens. It's not until I change the name of that method to be my button that it will now start reacting again. So yeah, this is the easier way to do event handling with control P5. Basically, whatever the name of the object is, like control P5 will set up a new event in this format. However, that isn't always necessarily the most useful thing, because when we have something like this, so now we have this color picker event. So when I set a color, it's going to call this event and we get this value, this integer value thing. However, if you look at it, these numbers are coming out just like all over the show and don't really seem to have any sort of semblance to anything which is going on the screen. That's because we need to break the red, green, blue, and alpha values out of this. The close bracket there. So now if I do like this, you see 125, and it's 125, 255, so 89, 123, and 164. So by calling these functions here, red, green, blue, and alpha, I can actually break the value out of, or the red, green, blue, and alpha values out of this integer value. So, you know, it's getting a little bit hacky now. You know, it doesn't feel quite so natural. So the alternative way to do that is control P5 also has this other way of managing events, which is with the control event method. So this control event method gets called by control P5 anytime anything happens at all on the screen. And we receive this control event object that we can basically look at to see what has happened. So control event method object, if we go in here, no, not callback event, control event. So if we look in that, it's got a bunch of different things. So get name returns the neighbor's name, controller's name, get label, get ID, etc., etc., etc. But we'll start with the most obvious one, get name. So now when I click on my button, we'll see my button pops up down there. If I click on color picker, picker 1 pops up. So it's basically, again, using these names here to identify between the two of them. So then we can start looking at that. So if c.getName equals my button, println the button was clicked. Else if c.getName equals picker 1, println, the color picker was right.
So 2 equals.
Oh yes, sorry. And actually, these are methods as well, so I would have found out soon enough once I tried to run it and it had complained. Yeah, so now if I click on that, the button was clicked, and if I change this, the color picker was manipulated. And the reason why you might want to do things this way or this way is, you see here, we can only ever receive an integer, which we then have to break out into red, green, blue, and so on and so forth. However, this control event C actually has a bunch of other variables. So if we look in here, we can get an array value, returns a float array, applies to example, which is missing, which is brilliant. Example range, there we go. And so we can get a float value, we can get we can get an array value, we can get a floating point value, so on and so forth. So what we can actually do now is we can go c.get array value, and rather than needing to convert from our integer into like our integer which represents the red, green, blue, and alpha values combined, we can basically just get an array value for each of these. And now you see it's been manipulated. 255, 255, 127. Because they're floating points, occasionally there'll be a bit of floating point error in there. So you can see it's 127.00001. 255, but we could just round these to the nearest integer using round or something. Oops. Round. And yeah, color picker was manipulated 255, 255, 128, 255. So it's exactly the same thing. It's up to you which feels more natural, more comfortable to you. Again, you know, it's sort of like this is still event driven, but it's more polling because you get it and then you have to check which object it was, the button, the color picker, the range box, whatever, which one it was, which fired the event, and then modify it accordingly. This one is more event driven. It basically says, oh, my button has thrown an event, and then you just do what you want with it. But yeah, so those are basically the two ways that the Control P5 library allows you to handle interaction. Again, I'll make these slides available if you want to have a play with them. Otherwise, there are plenty of examples. If we look in the examples list for Control P5, which just pop up when you've copied the library across, that you might want to have a look at for how to use it for various controllers and whatnot. So yeah, obviously not the only one. Another one which is pretty popular is this interfacea one. Which provides us with various bits and pieces, so buttons, radio buttons, and so on and so forth. I haven't actually used it much. I don't know how it compares to Control P5 as far as how many objects and stuff are concerned, but I don't think it has anywhere near as many. I think it's got like buttons, radio buttons, text fields, checkboxes, password fields. Not a huge amount of stuff anyway, but you know, the good thing about this website is it does actually allow you to have a look at the code before you start doing anything. But you know, you can get all the code and stuff for Control P5 by installing it anyway, so it's neither here nor there. Now, just one thing I will mention, because you might run into, particularly if you try and do this, when I was trying to run this before, it wouldn't let me run any of the examples, and you might find on some of the websites it won't let you run examples, Java won't let you run examples. What you might need to do is go into, like this is Windows specific obviously, go into the control panel, and in here you'll see Java. If you open Java, open the security tab, and then you can edit site list and add exceptions to the site list. So to get this interfacea one working, I have to add superstable.net to the site list because I don't like it's not an HTTPS one, and it was just packing a sad basically when I tried to run the examples on there. So yeah, if you're having trouble with it, have a look at the security things in the control panel settings. All right, so we just got another 20 minutes, I guess. So we'll just finish up. So this is the interfaccia one, which provides a few bits and pieces. But to be honest, I think Control P5 is probably a better way of going. This one's far more limited, but potentially you might like the syntax of this one a bit more. You just might, if you're only doing a few simple things, it might not be so bad. But yeah, so that's interaction. Everyone happy? Any questions? Anything? Obviously, it's just a very, very short dive into it because that's pretty much how everything goes in this course. We're just trying to expose you guys to as much stuff as possible, and then you can decide what is of interest to you, and then go a bit deeper into that. But yeah, we'll jump into we'll start having a look at graphics now because this starts pretty easy and then gets really complicated really quickly. Sorry. Yeah, so basically we're going to be looking at programming graphics. So we've already looked at some basic stuff, how we can draw lines, circles, ellipses, rectangles, do some basic color, stuff like that. However, now we're going to jump into a bit more complicated stuff. We're going to look at transformations, so in 2 dimensions and 3 dimensions. We're going to look at creating motion and animation a little bit, sort of, not too much detail. Looking at bitmaps and pixels, so loading images in, attaching them to stuff and doing stuff with them, and textures. So, processing. Processing is built on top of Java and uses a bunch of Java stuff for rendering its graphics. There should be another one in here somewhere. But basically, there are multiple what's known as multiple rendering types. So in processing 2, there are 4 rendering modes. The default renderer, which is built on top of Java. P2D, which is, I think, built on top of OpenGL, but supports mainly 2D stuff, so GUIs and stuff like that. P3D, which is built on top of OpenGL and allows full 3D graphics. And PDF, which allows you to basically render your processing sketch to a PDF file, which can be kind of useful if you want to create like printable stuff or whatever. To access it in processing, whoops, where are we? To access the various things in processing, if you remember in our setup method, we have that size function, so we can say size 512, 512 like that, create a window of a certain size. There is actually another function overload of the size method, which allows us to define what sort of rendering window or rendering type we want. So we can do P2D, we can do P3D, or we can do PDF. I'd highly recommend having a look at the P3D and P2D, whatever, modes in, or like tutorials in on the processing website, because they go into quite a bit more detail about what the various rendering modes do, what they're good at, and stuff like that. But there are differences even between the default renderer, which uses Java-based stuff, and the P2D, which you'd think would be the same, but is slightly different. Let me see if I can find a good example. So, GUI, need to find something, drawing maybe. So, you guys, badly out of focus. So we'll see if we can get this visible. So this is using the usual Java canvas, and if you notice, like the outline on the circles is quite smooth. So it sort of looks like it might have had a little bit of anti-aliasing in there for sort of smoothing out the rough edges and stuff. Let's have a look if this is going to be a good example for the E2D one or not. Sort of. It's a little bit hard probably to see on the projector, but on the screen is a bit more obvious. Like the circles just aren't quite as smooth. They're a bit sort of jagged and rough around the outside. Certainly there are better ones, better examples which show this. This one work. Let's see. Probably not going to be much better either. But certainly if you grab some of the more what was the name of the website which has all the, is it Open Processing? Has all the demos on them. Yeah. So we'll see if we can find a nice pretty one in here, and then if we switch it over, hopefully it'll be a bit more obvious, the difference between the two of them. Yeah, that looks pretty. Let's see if we can break it. So yeah, again, quite smooth. And if I pull it into P2D, hopefully it's not going to work very well at all. Brilliant. So yeah, there are differences between the two of them. You can sort of see that. Oh, okay, so it is running. It's just incredibly slowly for some reason. You can see like just sort of the pixels and stuff are a lot jagged, more jagged in the P2D examples. And for whatever reason, this one is running obscenely slowly on the 2D renderer. I'm not 100% sure why. It could potentially be this laptop. But yeah, so there are differences between them. We're not going to go too much into what they are for, well, yeah, in this course, what the differences are. But basically, one of them, I think, is just using OpenGL's generic. We are currently using the high-performance GPU. One of them is using, the regular one uses Java's like native 2D windowing stuff, and then P2D uses OpenGL, which typically means it'll run faster on a graphics card, or it actually pushes some of the processing up to the graphics card, which is kind of nice. But yeah, P3D is the other one, which allows us to do three-dimensional information. So it's kind of OpenGL-y, the way it works. Let's see, hopefully this one's still working. Oh, here we go. Actually, this would have been a good one to start with. Let's just have a look. P2D. Yeah, so again, it's pretty hard to see on the projector, but you can sort of just make it out. Like, there's no anti-aliasing or anything on any of the lines. They look more jagged. But yeah, anyway, I digress. So when we're doing sort of these OpenGL, like, have any of you guys had any experience doing OpenGL graphics? No? Okay, so this will all be fairly new to you then, but basically when you're doing 2D and 3D graphics using the P3D stuff, it's quite OpenGL-y, which means nothing obviously. But basically the way it works is we have a bunch of ways to sort of manipulate what's known as the current projection of the 3D or 2D world. So the projection basically defines, when we draw stuff, where they're going to appear, what their scale is going to be, whether they're going to be rotated, so on and so forth. So we have these functions, translate, scale, and rotate. So translate allows us to move. If you think about it, like if I gave you guys a pen and, you know, put your hand down and said, you know, start drawing, like draw a picture, like you draw it there. The equivalent, I guess, in OpenGL, if we look at just the 2D case, would be if we have a piece of paper like this, and you know, I put your hand down the middle and I say draw a picture, so you draw a picture. Translate would be like if I moved the piece of paper. So your picture's still going to be exactly the same, but because I'm translating the page, it's going to end up in a different place on the page. Rotate is the same thing, except I'm rotating it. So, you know, if I do, so if I'm doing, say, an L, no white paper around, anyone can see. Actually, hold on, I'll just use the back one of these pages. Now, if I start off with, hopefully you guys can see this, if this is what's known as the origin of the world here, and if I say draw a box or draw an L shape there, you know, it might look like that. So this is the origin, I draw an L shape and it looks like that. Then if I say translate it this way, and I draw an L shape, I'm going to draw exactly the same L shape, but it's translated. If I translate it this way, obviously it's going to be that way, and if I translate in 2 dimensions, it's going to be that way. Rotating is the same thing, so if I start drawing here and I rotate the page like that, I'm going to draw my L shape, and it's going to look exactly the same, but the end result is that it's been rotated, and you know, so on and so forth. And we'll look at this other things regarding order of rotations and stuff coming up. And obviously scale is just changes the size. So if I was to draw this at 1 by 1 scale and then I was to draw it at 2 by 1, it'd be twice as large as it was prior. And then we can also save and restore the state of the canvas. Now this comes in quite useful when you want to draw multiples of the same object. So say I want to draw 5 boxes. What I might do is I might define what a box looks like. So that's, you know, what a box looks like. It's just a rectangle. And what I could do is I'd say, okay, draw a box, and then I'm going to translate by 5, and I'm going to draw a box, and I'm going to translate by 5 and draw a box, and translate by 5 and draw a box, and so on and so forth. And so as far as what's doing the drawing goes, all it knows is it's just drawing the same thing over and over again, but we're just moving the canvas slightly at each stage. What we can also do is we can, with what's known as push matrix and pop matrix, we can save the current state of the matrix and we can return it. So let's say we want to draw a box here, and we're going to say push matrix, so we're going to save that as 1, and then we're going to draw another one. We're going to translate over, so move over to the right and draw a box, and then if we call pop matrix, we basically get the last one, so we move back here. So now, you know, my first command would be push matrix, so we're going to save this state, and then we're going to translate, say, 10 units across to the right. And then I'm going to pop matrix, and that'll basically take me right back here, and then I could say translate 10 down, which will move me down here, and I can draw here. So basically, it allows us to save where the canvas was when we last drew something, and then we can continue working from there. Might seem a bit arbitrary at the moment, but there are good reasons why you want to do that. And hopefully this one here will make that a bit more obvious. Right. So what you can see here is, this is a nice wee sort of example. When I move the mouse from left to right, that joint on the left swings from left to right, so it's basically rotating it based on the XY position of the mouse. And when I move up and down, it swings that second joint. So what we can do is I can actually move the mouse. If I move it to the top left, it's like an L. And then I move it to the bottom right. Basically, one of them swings 180 degrees in one direction, the other one swings 180 degrees in the other direction. And the way that works is pretty simple, really. All we do is we have 2 angles. So the angle of the first one, which would be this angle here, the angle of this first one, which rotates around, and then the angle of the second one, which is the angle from whatever this one's called. It's the second part. So we basically figure out the 2 angles. We push the matrix, so we save the current state. We draw the first segment, and we do that by translating it to the right place, rotating it by that certain amount, and then drawing a line, and then we call the second one. Keep in mind, as I said, or didn't so much say explicitly, but sort of generally implied, these mutations to the canvas are accumulative. So if I move by 5, and then I move by 5 again, I'm now 10 away from where I started. If I move by 5, move by 5, move by 5, I'm now 15 away from where I started. So they add up until you call push and pop matrix to basically return back to where you last saved it. It's the same thing. If I rotate by 10 degrees and then rotate by 10 degrees, I'm now 20 degrees away from where I started. So basically what's happening, we draw the first segment at angle 1, so we move it out to this position here, and we rotate it by angle 1, and then we draw it. Sorry. Then we draw our second segment, but we draw it from where the first one ended. So including the rotation and everything like that. So what I can do make it maybe a bit more obvious. So if I separate these two things out so that they're not connected. So there is one of them at the top, and there is one of them at the bottom. And by calling push matrix and pop matrix, basically I'm separating what happens to the two of them out. So the first one is drawn with the first rotation, and the second one is drawn with the second rotation. However, if I get rid of the stuff in the middle, we draw this first rectangle, or the first line, sorry, at whatever rotation we want, and then we basically save the state at that point. So we say, when we start drawing the second one, it's going to continue on that downwards lean, and from this point here, so it will continue like that, but then we adjust the angle using angle 2 here to pull it back up a wee bit. So yeah, if I just set that so we don't actually rotate the second one independently, you'll see we draw a straight line effectively, but it carries on with the rotation from the first one. Yeah. So it's a little bit complicated and confusing to get, but basically, if you sort of think about the example I gave here, we're always, if we rotate it, we just keep drawing. So as far as this drawing method is concerned, it's just drawing the same shape over and over again. It's just the world gets rotated a little bit as it goes. So everyone happy with that? Sort of. It's really one of these things which it's best to have a little bit of play around with until you sort of get the head around it. So yeah, that's 2D graphics. 3D is pretty much works exactly in the same way, except obviously instead of just having an X position and a Y position, so X being across the screen, Y being up and down the screen, we also have a Z position which defines how far into the scene, into the screen things are. So there's two options which are supported within processing. There's P3D, which is built on OpenGL anyway, but it's been integrated nicely into processing. It's easy to use. You can enable it easily, and then you can use raw OpenGL yourself if you feel that you need to, which provides full graphic support to everything that your video card will handle. However, it can be quite complicated, and we're not really going to look at it in this course because P3D will cover 99% of the stuff that you're ever likely to do anyway. So yeah, just to let you know that there is, if you do get to the point where you've run out of options with P3D, you're trying to do something which just can't be achieved, there is OpenGL, but we're only going to focus on P3D. So let me copy and paste the scene. And voila, we've got 3D graphics. So nice and easy. If we look at the code, it should be fairly easy to figure out what's going on for most of the stuff. I'll just split it up a wee bit. So first line of code, create a window 640 by 480, and we're going to be using P3D for graphics. So processing those straight off the bat. Yep, we're going to be doing something in 3D here, so we'll set up a 3D scene. Set the background to 0, which is black. We turn on some lighting, so you can see this cube here is lit, so one side here is quite bright, so this is facing towards the light. The side's kind of dark, and the side is a little bit lighter than the top, but not as light. So when you see something like this, you automatically know there's lights on. If we turn that off, I'll show you what I mean. So now you can see it's all lit to the same color. As far as it's concerned, there is no light source. There's going to be no shadows. There's going to be nothing at all. Obviously, if there was no light source in the real world, everything would be black. But in this case, often in graphics, it'll just render everything without any sort of shadow or anything like that. But you sort of look at that, and it might be a little bit hard to tell that it is actually a cube. So we turn the lighting on, we can see that. Yeah, so we push the matrix, we save the current state of the world. We're going to translate out by 130 and halfway across. So this is, we're moving out by 130, which will be out here 130 out this way, and then we're moving halfway down the image. So basically getting ready to place our cube. We rotate it by 1.25 degrees in the Y dimension, so X, Y, and Z facing towards us. So we're going to rotate around this way, 1.25 degrees. We're going to rotate in the X dimension, 0.4 degrees. That might be radians. I'll have to just quickly check. Or I say something which is wrong. Okay, so it's in radians. So you all know how to convert between degrees and radians. Okay, so basically to convert from radians to degrees, you multiply the number by 180 over pi, which I have in this calculator. Yep. So we go 180 divided by pi. It's 57 point whatever, and if we multiply that by our radians number, that'll convert it to 1.25. So we're rotating it by 71 degrees on the y-axis, and 4 times 80 over negative 22 degrees in the x-axis. And then we draw a box of size 100. So that's that one there. So if I get rid of one of those rotation functions and have a look, so now you can see it's basically pitched forward a little bit, whereas before it had pitched forward and rotated around a little bit. Now this is in perspective projection rather than orthographic, which is why it's sort of still, we can still see the side of it rather than just the front of it. So we'll look at different projection things on maybe Wednesday. But yeah, there's orthographic and perspective are basically the two. Perspective looks more realistic. Orthographic is more do like engineering drawings where you want to make sure that things you can actually measure the size of things and make sure they're going to fit in slots as well. But yeah, so that's rotating about. In fact, let's change this a little bit so we can actually see what's going on here before we set up. What I'm going to do here is I'm just going to make it so that it's very slowly rotates in the y dimension, or y-axis, sorry, so we can see. You can see it for one frame and then it just disappears. It's quite unusual. Something. Why that's such an issue drawing that box. Yeah, never mind, I won't do that because there's something going on there which I can't see at the moment, but we'll see other examples of it later on anyway. Just go back to the original code. Oh, actually, that's probably what it was. Yeah, I think the problem was when it tries to draw it again, it's not resetting the thing, so it's basically drawing it as an invisible cube over it. Yeah, so just go back to where we started. So setting up a 3D environment, background back, set up the lights, turn off the stroke, so the outline. We had stroke on. We turned stroke on. You can see it's now got the outline on the box, whereas before it didn't. So basically turning the outline off. Through our box. And we move it to 130 by height divided by 2, rotate it in the Y, rotate it in the X until the box of size 100 by 100 by 100. Then for the sphere, we turn off the fill and turn on stroke, so it's not going to have these nice filled edges, it's just going to have the outline. Translate it to 500 by height times 0.35, so somewhere in here. And it's actually pushing, this one is, the box is actually sitting a lot closer to us than the sphere is, so the box is at 0 in the depth, whereas the sphere is at negative 200, so it's sitting behind it a wee way, and then we create a sphere of size 280 and pop matrix. So we basically get everything all set up. So we can pretty easily, if we wanted to, we turn off no fill here. You'll see that the sphere is now filled. Turn off stroke as well if we want the lines around it. So yeah, and that's probably about all we have time for. Yeah, no, that's probably good place to leave it today. We'll continue on with this on Wednesday. 3D graphics is Wednesday.
Yeah.
So yeah, in the meantime though, have a play, download the Control P5 library. Get it working and processing, have a play, run through some of the examples. If you want to start having a look at some of the graphic stuff, go right ahead. We'll be looking at that in more detail on Wednesday. And I guess, have you guys submitted your first assignment? Whatever it was?
Not quite yet.
It's due this week, is it? Okay, so on Friday? Okay, so I guess next week we'll start. Yeah. Next week I'll give you guys a new assignment, which will have a bit of processing and maybe a bit of Arduino stuff. Any questions? Sweet. Cool.